Hi there, my name is Jay Staples and welcome to the post-production for Unreal Engine guide. We're going to be using the new ACOM Unreal Engine Animation Demo project created by Agora Studio, which is a 1-minute short film that demonstrates some of the new tools that Unreal Engine has for creating cinematics. So before we get into the nuts and bolts of how to do it, let's just play the short film after all the color grading and compositing, and then we'll chat about how we got there. So how are we going to get this scene from Unreal Engine into a final video? Well, we're going to be using two softwares, of course, Unreal Engine and then Davinci Resolve for our compositing and color grading. In Unreal Engine, we're going to be rendering HD plates using EXR with PIS compression, and we'll be rendering out the RGB and the Cryptomat pass in the ACES CG color space. We're going to be using the motion blur and depth of field that has been created in Engine, but we're going to be doing our lens effects and our 2D effects in compositing in Davinci Resolve. Once those renders are done and we're happy with them, we're going to conform the timeline in Davinci Resolve for our compositing and color grade. So let's check out our project setup. The core plugins we'll need for this workflow are the Movie Render Queue. We're going to need the Movie Render Queue additional passes. This will allow us to render Cryptomats. And lastly, the Open Color IO plugin. OCIO allows us to use the same color pipeline in Unreal Engine and in Davinci Resolve. And for this, we're going to be using the ACES 2.0 workflow. And for our Unreal Engine project settings, the core one we want to make sure we have is our working color space set to ACES AP1. By default in Unreal Engine, it's set to Rec 709. So if you render without changing the working color space, you're going to be getting Rec 709 scene linear plates from Unreal Engine. But for this project, we're going to be rendering in the wider color space, which is ACES AP1, and then using a color space transform to take us from AP1 to Rec 709 for our monitor to display. Before we jump into Unreal, let's chat a little bit about what we're going to be doing in Resolve after we've done our renders. We're going to set our color science to Davinci YRGB, our timeline color space to ACES CCT, and our output color space to Rec 709. In Davinci YRGB, this is considered a non-color managed project, which means we need to set up our own color transforms manually. The timeline color space, ACES CCT, is similar to ACES AP1, but the key difference here is ACES CG is the ACES color space in scene linear, and ACES CCT is the same color space, AP1, but with a log encoding. So it's more similar to an RE log or a red log or a Sony log if you've worked with any of those camera formats. The reason for converting from ACES CG to ACES CCT is because most of the Resolve tools are designed to work in a log space. So everything will work a little bit more consistently, making sure that we do this step of converting from CG to CCT and then back to CG before we go to our final color space, Rec 709, which is our display space that our monitor is expecting. For this project, we're going to be doing the compositing and the color grading on the same timeline. So we're going to be manually setting up a few color transforms here to manage our pipeline. We've laid it out here. So we're going to import the ACES CG renders from Unreal. We're going to do our compositing in ACES CG without transforming anything. Then when we move into grade, we're going to transform our composited ACES CG into ACES CCT, the log flavor for our color grade. And then once we're happy with our color grade, we're going to convert the graded ACES CCT footage into Rec 709 for our final pixel. Okay, so now that we know what we're going to do, let's jump into Unreal Engine and check out our movie render graph and have a look at our preset. Okay, so we're in the movie render graph that we've set up for this project. we've got one layer here going across the top. These are our global settings, so these will apply to every layer that we render out. Then down the bottom here, we have two branches. This top one is our RGB render, and the bottom will be a Cryptomat layer. Now, a little bit of a helpful tip for working with the movie render graph is that the graph resolves from right to left. So what will happen is it will actually start at the outputs, and it will go back, applying the settings as it goes until it hits the input. And if it hits the input, then it will go, yep, that's a valid workflow, and it will add it to a preset. So one way this works down here is using this branch node. So you can see I haven't plugged anything into the false node. So what that means is if I haven't ticked render Cryptomat, meaning this Boolean value, this true or false is false, then you see this false isn't connected to anything, which means this layer won't resolve. So we won't get any Cryptomat. This is one way of setting up a yes or no if statement in your movie graph. So what we'll do is we'll work from right to left, and we'll start at the globals area. For this setup, we're going to use the EXR sequence multi-layer setting. A multi-layer EXR is one EXR file that has each layer embedded within it. So we're only going to need to import one video file, and we're going to get both our RGB and our Cryptomat data inside of the one file. Here you can see we've set up our file name format. You can use tokens to make the versioning a little bit easier. You can see what they are if you go up here. Let's say I start typing in a new variable, open bracket, and we've got all of these tokens that we can use for our shot naming. I've turned off the multi-part component, and we've set our compressions to PIS. PIS has a great balance of file size and quality, so we're going to use that. But if you're finding the file sizes are getting too large, you can also try DWAA or DWAB, sorry. Let's move over to the global output settings. Here you can see I've exposed some variables, and I've plugged in a custom value into each of these variables. You can create variables on the left here by clicking this little plus. This creates a new field. By default, it's a float, but you can change it to any other type of information you need. And one of the variables I've set is the number of handles I want in this shot. So here I've exposed that here, handle frame count. Let's delete this blank variable. You can see I've created a variable over here called frame handles. It's an integer, so it's a whole number. And I just plug this node into the exposed parameter here. Now, whatever value I set here is what will resolve in the movie render graph. So at the moment I've got no handles, but if I wanted to do 4 by default, I could change this number here to 4. These variables on the left here will show up in your movie render queue. So if I go back to this first job that we've got here, I've selected the movie render graph main, which is what we're looking at. And on the right here, you can see the variables that we've created. So here for this job, I could change the frame handles to 4 or 8, whatever we wanted to do. So here I've set our renders to be HD 1920 by 1080 and our output frame rate to be 24, matching the timeline frame rate in this project. Moving over to the global game overrides, I believe this is all default. This essentially refreshes our scene to use everything as high quality as possible and sets our engine scalability quality to cinematic. Cinematic will get you the highest quality motion blur, depth of field, and so on. Next, the warm-up settings. This is the number of frames that Unreal Engine will pre-render before hitting record on the camera, so to speak. So if you've got any effects that need some time to warm up before your camera starts recording, like a destruction simulation, you'll need to play with this number here to get the right number of warm-up. We've also ticked emulate motion blur so that we're calculating the motion blur before the camera starts recording in the scene. The next node I've used is the sampling method. Generally, it's recommended to use temporal sampling rather than spatial where possible, and you can set this simply here by creating a variable and plugging it into this sampling method node. Lastly, for our global settings, I've created some console variables that we've set. There's only a few here and you can customize it. Notably, I've increased some of the memory sizes for the streaming pool and the ray tracing. This helped avoid some crashes while rendering. And another important one was motion blur separable. This adds a second motion blur pass that smooths out noise for a higher quality blur. If you're doing your motion blur in Engine, I would recommend turning this on. Okay, that's our global settings. Let's check out our RGB render layer. So outside of your global settings, each one of these outputs down here is a layer, and they all need a render layer node in order to validate. So this is just here to validate this path. The important bit is over here in our deferred renderer. There's a variable, spatial sample count, being plugged in here. And for all shots, well, I've just left this at 1. For the anti-aliasing method, I went with TSR. However, the new SMAA is quite good as well. But I found if you zoom in on some of the finer details, it would create some little artifacts. So generally, I found TSR to be more reliable. Next up, in the post-processing component, you're going to want to turn disable tone curve on and allow OCIO off. What this does is it disables Unreal's automatic Rec 709 conversion. So when you have this enabled, you're going to be getting your working color space in scene linear. So because we set up our project, just type in color space. Because our working color space in Unreal Engine is ACES AP1, when we've ticked this, and have OCIO off, we're going to be getting scene linear renders in ACES CG, which is perfect for compositing. Let's move down to the Show Flags menu, and in the Post-Processing component, this is where we can set what post-processing effects from Unreal Engine we want to keep and which we're going to be doing later in compositing. So we're going to be keeping the in-engine color grading, depth of field, and eye adaptation. Eye adaptation is Unreal Engine's auto exposure. So generally, we always want this on to be using your in-engine exposure setting. We've got local exposure and motion blur enabled, as well as the tone mapper here. When you have disabled tone curve enabled up here, you also want to keep this one on down here. If these two boxes are out of sync, like this one is unticked and this one is ticked, your render won't look correct. And then for the post-processing effects we've disabled, we've gotten rid of bloom, camera imperfections, film grain, lens distortion, lens flares, any post-process materials, scene color fringe, or vignetting. These effects we can do later on in compositing. One last note here is that if you're happy with the in-engine chromatic aberration, bloom, lens flares, then feel free to keep those in-engine and not do that in compositing. The rest of the workflow will still work just fine. You won't need to use the lens effects node that we check out later on. So let's move over to the Object IDs node. This is our second layer in our multi-layer EXR render. I've called it Cryptomat, and Objects IDs is a second render pass that captures purely the Cryptomat data. For ID type, I've left this on full. This allows you to select any material, any object in compositing later on, and it doesn't group anything. So this gives you the most amount of flexibility, and that's the movie render graph. So let's put it into work. Head over to our movie render queue, and let's just render one shot. I'm going to turn all of these off. Let's render shot 50. So I'm going to turn this one on. We've selected the MRG_main, which is the graph we just looked at. Now over here on the right, we can set some locations. So output directory, I'll leave that on default. Spatial and temporal samples, I'll leave those on default as well. Warm-up frames, let's do 150 frames of warm-up. Yes, let's render the Cryptomat. I'll keep our frame handles at 0. I don't think we need any handles for this shot. If there's a previous version, let's override it here. So I've ticked that on. And for versioning, let's leave that as default. Once that's set up correctly, let's hit render local. And after a moment, Unreal Engine will start rendering. So you can see right now, it's calculating the 150 warm-up frames before starting. We know it's working correctly when we've got our RGB on this side and the Cryptomat layer rendering on the other side here. And now that the warm-up's done, Unreal Engine has started rendering. Okay, let's say this render is complete and we've rendered every shot in our sequence. Now we want to get this timeline into Davinci Resolve. This is quite easy. You can just go over to our Shots tab up here. Right click that and go Export EDL. Save this somewhere. Now let's move over to Resolve and we'll import that EDL. We'll go Timelines, Import. Choose our EDL and hit Import. Select OK. No, we don't want to look for any shots just yet. You see the timeline has been imported here. Now, Unreal Engine doesn't know which version you want to use in your edit, but it is telling you what the shot name is. So here you'll have to go in and grab your render. So let's say I've got render 50 here that we did before. Go to this render shot, render 50, right click this, conform lock of media pool clip, and then our shot falls into place here. Now, before we get too deep into Resolve, we should also talk about some of the 2D effects workflows on this short. So in Engine, they've used camera projections to create 2D effects on top. So here there's an effect where this robot shoots a blaster. If I turn that back on, we can see that here. And this is just happening in a media clip on the timeline that they're doing with a camera projection. But in this case, I knew it would look nicer if we took these 2D effects out of the Unreal Engine render and then applied them later on in comp so that it would react to our lens dynamically. So to do that, I just disabled the projection layer down here, which gets rid of that, and then rendered this as it was. Then to get these 2D effects to apply later on in comp, then to get these 2D files to apply later on in comp, we go here, Properties, here's our media source, find that, open up our image media source, and here we've got the file path of where it's stored in our project. So you can just take these and move these into compositing to do those later. And one more thing to talk about before we jump into Resolve is our OpenColor IO plugin. So part of the reason why we need OCIO is that the default look that Unreal Engine has here in the viewport can't be recreated in Davinci Resolve because I don't believe Epic Games has released their tone mapper as some sort of plugin that you can use in Resolve. So we need to bring our own tone mapper in to be able to use the same scene data to Rec 709 in Engine and in Davinci Resolve. What we're looking at here isn't just what's happening in Engine, it's what's happening in Engine through a certain digital film stock, we'll call it. This is the Unreal Engine ACES CG to Rec 709 viewing transform. It's proprietary to Unreal and something that we can't just replicate in Davinci Resolve. So we've brought our own in. That's why we needed the OpenColor.io plugin. If you go to this lit view here and go down to the bottom, you'll see this color management OCIO display. I've already set it up. It's turned on and it's converting from the scene ACES CG to the Rec 1886 Rec 709 ACES 2.0 viewing transform. So if we didn't have this on, our viewer would look like this. And to get this exact look, we couldn't do in Resolve. So if we were lighting to this particular view, when we brought it into our color grading, we wouldn't be starting at this point. We would be starting at this look. These color transforms will do more than just change the contrast like what you're seeing here. They'll also change the highlight behavior, particularly in saturated colors like this. So to cover a wide range of lighting scenarios, we want to set up the same viewing transform for both softwares. So to set this up, we need to create an OCIO asset. In order to do that, we need to go to our content drawer. I've made a folder here. You can see I've got a couple here. I've got one for ACES 2 and one for OpenDRT. For this project, we're using the ACES 2, so I'll show you that configuration. But let's build a new one together. So we right click, type in OpenColor.io configuration. Let's name it something. Let's go OCIO ACES. And now let's configure this to work with our scene. So we'll open this up. So here we need to give it a configuration file. This is something you can download online. I've left a link in the description of this post somewhere. So if you follow the link, you should find yourself at this GitHub repository. We can find it at the bottom of the page, so we'll scroll down. And the one that we want is Studio Config All Views v3.0. So we'll choose our configuration. We'll add a new desired color spaces. These are the potential scene spaces that you'll be working in. Because we know we set up our working space to be ACES CG, we'll select that. So we go add element, ACES CG. Then in our desired display views, we'll go plus, add a new one, go Rec 1886, Rec 709, ACES 2.0 SDR. Now we're done with this configuration. So we'll hit save, close that. And now will be available in our color management OCIO display. So we change it from, I had this one as set as ACES 2, but we just made one together called OCIO ACES. Select that. It will say invalid because we need to specify the color spaces. So the first one, scene space, is ACES CG, and the final space, Rec 1886. And there we've got the same viewing transform that we're going to see in Davinci Resolve. Okay, so now let's move into Resolve and check out our color management setup. These layers here are my proxies, so I'm going to turn these off and then turn on our live comp and color grade layer. Let's move over to shot 50 that we were looking at before. Okay, so what's happening in each step of the process? Before we mentioned that we're importing an ACES CG, compositing in ACES CG, transforming to ACES CCT, the log flavor for grade, and then transforming to Rec 709 for our final pixel. So in Resolve, the Fusion page, the compositing section happens first, and then the color page happens after that. So we know these files initially are in ACES CG. So if I move into Fusion page, I'm going to move my workspace to the mid flow. I find this a bit easier to follow. We can see all of this work here is then happening in the ACES CG space. Now, when you first open up Fusion, it might get a result that looks a bit like this. The reason for that is that we're looking at the scene linear data, not the tone maps Rec 709 data. This is where we'll set up another viewing LUT, just like what we did in Unreal Engine, to be able to view the ACES data properly. We're going to turn on our viewing LUT, tick this little drop down to have a look at what we're doing. Got ACES transform enabled, go edit, and you can see we're using ACES 2.0, ACES CG color space conversion to Rec 709 BT 1886 or Gamma 24. With the ACES reference gamma compress on. This is just a viewing LUT, so we're only going to see this result in our viewer here. And once it goes through all of our compositing, this media out is going to send it back to the timeline like this in ACES CG. So all of our work will still hold and turn that off and on. That's all still happening, but it's staying in ACES CG all throughout the compositing. We'll get into this node graph and what's going on later. First, we're going to go to our color page and see how we took this ACES CG information and brought it into Rec 709 in the color page. So first of all, I'm going to turn everything off. This can all go off. Great. So the way I've set this up is by using groups in Davinci Resolve. You can add a shot to a group by going right click, add it to new group, or groups, assign it to a group you've already created. Groups are essentially another layer that you can add to a shot that happens before and after your clip level adjustments. So here I'm in the clip level. I've got the 3 grades that I've done here on this shot. If I go to the group pre-clip, you can see this is happening before we grade our actual shot. So this is another ACES transform node that's going from ACES CG color space to ACES CCT color space. If I turn that on, you'll see it's going from the scene linear, very crunchy look into a log format. This would be the correct color grading space. Then if we move to our group post clip, you can see that we've got another node that's converting from ACES CCT to Rec 709 BT 1886 with the ACES reference gamma compress on. And now we're getting back to our normal space, because what's happened is we've gone from ACES CG, turned to ACES CCT, done our color grading, then we're moving from CCT, log ACES, to Rec 709, and we're applying the ACES reference gamut compress. You're always going to want this on when you're moving from a wide color space to a smaller color space, like what we're doing here. This prevents any overly saturated colors from clipping in your shot. And then for a final touch, I decided to add some film grain after the Rec 709 conversion. Now with that set up, if we go back to our clip layer, all of our color grading effects will work correctly as if we were in this log space, because that's where it's occurring in the pipeline. Because we know we've set up our clip space to be ACES CCT, this is where our color management timeline color space ACES CCT comes into play. When this timeline color space is set to ACES CCT, all of Resolve's grading tools are going to respond appropriately for the ACES CCT color space. Some of these tools work differently depending on what this is set to, so it's important to set your timeline color space to be whatever space you're going to be in during your clip level adjustments over here. For example, I've been grading using the HDR wheels. I quite like how they work and how they look. Here I've just done a bit of exposure down and pushed in some of the cooler colors. And you see, if I leave this effect on, and if I was to change this to ACES CG, hit save, we're getting a totally different look on our shot, right? Because we've set that incorrectly. And so we'll get the best results if we make sure that we set our timeline color space to be the actual color space that we're sending to our clip level, which we can remember here, ACES CG to ACES CCT. Let's go over a little bit of the color grading philosophy that we used on this short. I've laid out a little template here. We start with the main grade, we do any secondary color effects, and then we use any windows to help shape the lighting. So for example, on this shot, I'm helping control the light direction here. This is off, this is on, by darkening off the left side and emphasizing these volumetric rays on the right side. Typically, you'll want to do the same order of operations on each shot. So here I'm doing the base grade first, secondary effects, then windows. And I'm doing the same thing in the same order on each shot. So in our base grade node, I've opted to use the HDR wheels. I find the HDR wheels really direct in getting straight to a nice looking image. So let's regrade this shot from scratch and just see the thought process to creating this look. Okay, so looking at this image, let's have a think about what we want to do to it. So the first thing I'm noticing about this shot is that there's a bit of a magenta wash going over the image. So the best way to do that will be to push a little bit of green into the image to neutralize that magenta tint. Generally, I feel the shot is a little bit high key. I think we could use some more shadows and contrast to dramatize it a little bit. So I'm going to start by doing a global wheel. So we'll start by darkening the shot a little bit. That's feeling nice, about a third of a stop down. And then let's take some of that magenta out. So we can grab our dot here, pull towards green, play around, try and find a nice spot about here, a bit further. There, that's looking nice. Let's go before and after. You can do Control D to turn a node on and off. So before, after, that's looking nice, a little bit more dramatic. And then I think we can crunch up the shadows a little bit more. So I'm going to pull down our exposure on the shadows area. About there is feeling nice and dramatic. And that's the first base look in for this shot. Then for our secondaries, this is where we can think about changing certain elements of the shot. So if for whatever reason we felt that these reds were too saturated or too bright, we could do something about just the reds instead of the whole shot. One way to do that is by going to the curves here, click that, and then we have some options on how to adjust certain hues in our image. The two most common ones to use are the hue versus sat, which is this one here, and the one to the left of that, hue versus hue. Let's select the reds by choosing the red pre-selector here. And you'll see it's put 3 dots, one on the yellow hue, one on the red axis, and then one over here on the magenta. So if I was to click this red one and drag it down, for instance, you can see all of those reds are now going greeny yellow. Pull it up here, and now they're going more pink. I'm going to reset that. I like the color here. Then let's move over to hue versus sat. Do the same thing. Click the red pre-selector, pull this down, and you can see now we're desaturating all the reds. For this shot, I'm going to leave it on neutral. But this technique I did use on some other shots. For example, I believe this shot, when the big guy opens up these doors, I did hue versus sat, and I pulled a little bit of the red out. which took it from this very bright red to a little bit more of a dim cinematic red. Going back to our shot with the robot, let's emphasize the light direction in this shot. So here I noticed our light was coming from right to left. We can do this by using a window. So I've got an area here set up for windows. You can create a window by going to this power windows area here, let's say with a circle. And if I was to change something, we're only getting that adjustment in this window. But let's reset that and use a gradient. So the gradient is this bottom one here. Let's move that into position, something like this to match the light direction. And let's add a little bit of exposure. That's looking nice, 0.75, so 3/4 of a stop. And now let's say we also wanted to do the opposite, so darken the other side of this gradient. What we can do is by adding an extra node here, we can move this, let's zoom in a little bit. These blue outputs on our nodes are the mask. So what our gradient is doing, if I click this mask button up here, the highlight, we can see that this area where we can still see the image is where it's being affected, and we can see the mask more clearly with this button here. So areas that are white are being more affected by this node, and areas in the black aren't being affected at all. So let's take this mask that we're creating on this node, which is the blue output here, and connect that into our next node. Let's turn off our highlight mask so we can see what we're doing. Then we'll move over to node 4. Now at this moment, this node is still affecting the same area. If I was to go up or down, it's still hitting the same mask, but we can invert the mask just for this node. So now that we've brought it into this node, I'll go to this matte area or key area, key output, and this button here inverts the mask. So you can see it's inverted here. Check out our mask, it's doing the opposite of what our previous mask was doing. So then on node 4, we can take our exposure and pull it down. And now we're darkening the opposite side of the mask that we pulled before. So the final result, if we select both of these nodes, Control D to disable, here's our neutral shot, and then here's the shot with our color grade. What's nice about inverting the mask and setting it up in a separate node is now if we decided to move this light or change the gradient power, it's updating the second node in real time over here. So we only have to set this up once and we can then play with where exactly we want to place this gradient. I think a little bit over the character is looking nice. And that's a final grade for this shot. Now for the most part, that was the extent of what we did to achieve the color grading, but I did want to show you one shot. This shot here, where we remember that the lighting goes from blue to red, you can see down in the bottom right, we've added some keyframes here. So on corrector 3, node 3, we've got a keyframe on here happening at this frame right before the lights go down, and another keyframe as the lights go up. So we can enter a different color grade on this frame and on this frame, and it will blend in between them on the node that we've done that on. So for this shot with the blue on this keyframe, this node is actually blank. It's not doing anything here, but on the keyframe when the lighting changes, we can see that we've done some contrast down and we've pushed a little bit of warmth into our global exposure here, taking it from this image to this image. Now the way we can do that to set up these keyframes, let's turn this off. I'll make a new node, corrector 5, and we can see in our keyframes layer, which if you're seeing this, the scopes, you can click the keyframes button here to bring up the keyframes layer. Let's move to this bit just before the lighting change. Go to our level 5, corrector 5, right click, go add dynamic keyframe. Dynamic keyframes are the blendable keyframes. Then we'll move the playhead to after the lighting change. Do the same thing, right click, add dynamic keyframe. And then here we'll input our color change. So remember we exposed down a little bit. So now this side of the lighting change is looking good. We'll go back to before the lighting change and we can see that our node is adjusting in real time. Here it's not doing anything. Back over here, we're getting our adjustment. Okay, so now that we've got a handle on our color grading, let's jump back into Fusion and check out how we've composited these shots. I thought this shot was a good example to show off Cryptomats because the lighting here on this face, where he's in the shadow, is quite dark. And I wanted to just brighten up this character rather than the whole shot. So I've got our setup down here, but let's make a new Cryptomat node. Plug it into our stream. If I press 1 to view that, the Cryptomat node is going to pull out the Cryptomat data that lives in our EXR. We can tell it's got it because up here near where we set up our viewing light, where it says main, if we click that, actually back here on this node, click main, this shows us our layers that we have in our EXR. So we've got the main RGB layer and then our Cryptomat data down here. So now that we've plugged Cryptomat into that stream, Cryptomat is going to read that data and allow us to select objects to create a mask. So to do that, we go select matte, hit the eyedropper tool plus, and we just start selecting what we want to select. So let's do the character, the face, the eyes, inside the mouth bit there. And now we can see that we've selected this character. It's added it to our matte list, but then to turn it into a mask, we need to tick the button output to alpha. And now it's made the background transparent. In our viewer, if we press A on our keyboard, we can see the black and white mask that's being created by Cryptomat. We can scrub through the shot and see it follows the character and carries through the motion blur. Let's press A again to go back. And now that matte or that alpha lives in this stream. So let's add another grade node. I'm going to grab a brightness contrast node, plug it into the stream down here. Let's view it. And then for our blue input here, similar like what we did on the color page, if we connect our Cryptomat output to the blue input, now the alpha from Cryptomat is going to tell the brightness control node what parts of the image to adjust. Because we're compositing in scene linear, we know that the right tool to affect any exposure adjustments is gain. Gain in ACES CG or any scene linear is equivalent to exposure. So let's push this up a little bit. I believe I had this on 1.25, and we can see if we use Control P in Fusion is to disable a node, not Control D like it is in the color page, but Control P. We can see we're brightening up our character and not the background. So here what we've done in our main comp, let's delete this side work. I did 2 layers of this. So the first Cryptomat was targeting the full character. The second one was just targeting the face. So viewing here, I boosted the face up 1.5 times. And now we're able to see our character even when he's in the shadow. This is why rendering Cryptomat can be so handy, because to do this sort of thing in the color page would require rotoscoping the character. We're getting this data directly from the engine, so there's no need to rotoscope or track anything. Then after this, we want to start doing our lens effects. For this project, I created one lens node that does everything that we want to do. I've left this available for you to download if you want to use it. That's doing our lens effects, so let's view that. Now we can see our shot that has lens effects on it. This node is a macro, which means it is a pre-built Fusion comp with some exposed parameters that you can play with that's emulating our digital lens. This node was inspired by a node created by Alex Fry for use on Lego Batman. Let's play the preview. So as you can see, it's taking the original image, the render from Animal Logic, and then creating a procedural lens effect that's laid on top of the image. What's great about doing lens effects in post is that you can art direct them, and it doesn't require any re-rendering if for any reason you only need to change the lens effects. There are no color keys or if statements in the node, which help things work consistently in a procedural setup. If you want to read a little bit more about this node, I recommend checking out the write-up on fxguide.com. The link is on screen here. So back to our shot, let's have a look at some of the parameters that are available on our procedural lens. The first one up the top is global scale. It just controls how much light is going into the lens. So if we want to reduce the effect, we can bring the number down. If we want to increase it, we can bring the number up. Then the next couple parameters control specific aspects of the lens. So the first one is the glare. It works via screen space. So if you have a bright light up the top here, like this red light, it's going to create more glare of red on the bottom. The next parameter is the bloom. This is the glow on highlights. So let's zoom into this light here, crank up our bloom a little bit. So if you want to add more local glow to bright objects, you can do that with the bloom scale. Next up, we'll have a look at barrel. Again, it works on screen space. So if we have a bright light here, we're going to see a bright light appear on the opposite side of the screen. Let's turn that up so you can see the effect. So here we can see this bright red line down here is creating a flare on the opposite side. Next we have the anoline. These are the anamorphic horizontal lines that appear on bright objects. So again, let's have a look at this light, turn it up, and here we're getting our bright horizontal lens flares. There's a few more parameters that control the overall effect after all of these different elements are added together. Here we've got X blur, controls the blur of all your flares left and right. Y blur, same thing, just helps soften the effect a little bit at a low number. We've also got a vignette that we can apply in the lens area. So if I turn that down, we're getting darker corners of our screen. And then the last parameter is our chromatic aberration. You'll notice that this lens node has 2 outputs. If I hover over this output, you'll see it says ProLens Type A.comp out. So this output adds the lens effects on top of your image. The other output, let's have a look at that. I'll make a new node, connect it here, press 1 to view that. This node is just the lens effects without the base shot. So if you want to composite this in a different way, you can do that here. Okay, now the last thing to talk about in our compositing is the 2D effects. We talked about extracting them from Unreal Engine earlier. So let's go to a shot with some 2D effects. Go back to our robot shot where he shoots the blaster. So this area of our comp here is where we're adding our 2D effects. Media in 1 is just the PNG that we took directly from Unreal Engine. I've used the global in and out to sync it to the right point in the shot. Now if we turn off our viewing LUT, these PNG frames are in sRGB space, not ACES AP1. So we need to convert these from sRGB to ACES AP1. The sRGB space has something called a gamma, which is essentially a non-linear color. However, our comp in CG space is in a linear color space. So I've used a color space transform node to convert it from sRGB with an sRGB gamma to the output color space ACES AP1 with an output gamma of linear. When you have ACES AP1 and linear, that's the same thing as ACES CG. That's just a bit of color terminology, but just know when you have ACES AP1 and linear, that means the same thing as ACES CG. When you're doing a color space transform from a gamma space to a linear space, you don't want to include any tone mapping because tone mapping is used for compressing colors from a linear space to a gamma space. So we've set that to none. For gamut mapping, we've also also set that to none because we're going from a smaller color space, sRGB or Rec 709, to ACES AP1, the larger color space. Gamma mapping should be used when you're going from a larger space to a smaller space because you need to map the colors that are in the wider space into colors that fit in the smaller color space. For our advanced settings, let's start with white point adaptation. White point adaptation means it's going to change the white point in the color space. So whatever is considered white in one color space moves to be white in a different color space. The actual color of white can be slightly different between color spaces. So by keeping this off, we're keeping the intended white from the color space that we started in. For forward and inverse OOTF, we don't really need to cover that technically, but just know if you select options for gamma, input gamma and output gamma here, it will automatically tick those when you need them on or off. So we don't need to worry about that here. Let's keep them both off. Now, when doing a transform like this, because the starting values for our image in input gamma were always between 0 and 1, let's go view that. Mouse over the highlight here, and in the bottom left, you can see we've got a value of R1, G1, B1. This is the brightest pixel in our image. If we go look at our scene linear image, find a bright highlight, like this red line here, mouse over that, we can see that our highlights here are going up to pretty high numbers, 17 in the red channel here. This is because we're in scene linear. Now our screens can only display pixels from 0 and 1, so that's why it's clipped here. And our viewing light helps map those colors from 17 back down to 1 so that we can display it on our screens. The reason we have values going so high is because this represents real world light values. Essentially what we're saying in scene linear is if we have a pixel here at 17 and a pixel over here at 1, this is 17 times brighter than our pixel over here at 1. So if we've got a bright highlight like these lasers over here, we would probably expect this blaster shot to have a value similar to that, up in the 17 to 20 range. Going back to our color space transform, because the starting values were only in 1, we can see when we mouse over this, we're only getting starting values around 1 here as well. So we need to brighten this up to match values that suit this scene. That's why after the color space transform, I've included a brightness contrast node and increased the exposure by 15. So our values that started at 1 are now going up to about 15. So now this blaster is at a similar exposure to our glowing lights in the background. The last step was a glow node and then a merge node to put this on top of our shot. Because our blaster shot is the correct brightness now, our lens is reacting to that light correctly because it's sitting at the right level exposure for the scene. And that brings us to the end of the post-production for Unreal Engine guide. I have links to the OCIO configuration and the Fusion procedural lens macro here. You'll be able to find those in the description of this post somewhere. To install the procedural lens, you just need to drop the text file into the install location for whatever platform you're on. And if you've made it this far, I'd like to invite you to the Octave Unreal Engine community. We're a small group of Unreal Engine artists working in cinematics. If you're interested in collaborating on short films and other cinematics in Unreal Engine, then join us on the server and we can chat about some future projects. And if you want to ask me a question directly, you can reach out to me on Instagram at jstaplesfilm, or you can email me jstaplesfilm@gmail.com. Cheers and happy 2026.